Okay, so in this unit, our goals are going to be to look at real world applications, and then we're going to be solving various equations with exponents in them. So today we're just going to start with using formulas to solve problems, and then we'll kind of expand upon that in future lessons. So just as a couple examples today, we're going to start with substituting into a formula. So pediatric nurses use Young's formula, C equals A times G over G plus 12 to calculate a child's dose of medicine. C milligrams when the adult dose A milligrams and the child age G years are known. So it's basically the connection between what you would normally give to an adult and then how to change that into what to give to a child. Suppose the adult dose of a certain medication is 600 milligrams. Determine the corresponding dose for a 3-year-old child. Okay, so we know the adult dose is 600 milligrams. So we're going to put that in for A. And then G is the child's age in years. So we know that this is a 3-year-old child. So we're going to put in 3 for G. So I'm going to show my formula always when I'm plugging into it. C equals AG over G plus 12. And then tell me what you would get when you sub in. So what did you plug in? Okay, perfect. So when you go about calculating this, you want to basically just remember that there's technically brackets around the top and brackets around the bottom. So when you follow BEDMAS, obviously the top and bottom kind of need to be simplified first. So 600 times 3 would give us 1800, and then 3 plus 12 gives us 15, and then we can just do the calculation from there. Take a second, plug that into your calculator. Yeah. Perfect. So, oh, my pen's, oh, never mind, it's back. 120, and what does C represent in this case? In what unit? Okay. So then we'll get out 120 in milligrams, and then all of these types of questions, yeah, we can plug it into that bottom part there. So the child's dose is 120 milligrams. You would always give me like a therefore final statement for these ones as well. So far, so good? Yep. All right. So a landscaper wants to estimate the cost of fertilizing a triangular lawn with side lengths 150 meters, 200 meters, and 300 meters. One bag of fertilizer costs $19.98 and covers an area of 900 meters squared. She uses Heron's formula to determine the area of the lawn. So the area of the triangle with side lengths ABC is given by the formula area equals the square root of S times S minus A times S minus B times S minus C, where S is A plus B plus C over 2. Estimate the cost of fertilizing the lawn. Okay, so do we know A, B, and C in this case, the side lengths? What are they? Okay, so sometimes it's helpful just to draw a picture as well. So if we have a triangle, maybe we can just draw and label like ABC on this, just so we have a visual. You can also just list out like A equals this, B equals this. So let's say A equals 150. I'm not drawing this to scale, it's just so we have a visual. B is 200, and C is 300 meters. Okay. Do you have any thoughts on what the most efficient way to calculate this would be? So if this is our area formula, and then it also gives us like a secondary formula that we need to use to plug into this formula, which is this one here. So do you have a suggestion as to how we can make our life a little quicker here? What should we do first? Should I do the area formula first or the S formula first? Do I have S that goes into the area formula though? So probably would be most beneficial to calculate S and then use that in our area calculation. Okay, so let's do that. We'll do S equals A plus B plus C over 2. Figure out what that is. If you put this all into your calculator at once, just remember that there's brackets on top. Or you could do two separate calculations, obviously. What'd you get? Oh, you got one more. I got 325. 150 plus 200 plus 300 is 650. Oh, I think you have, this should be 200 and 300. You put 20 there. Oh. All right, so 325, I think we should get. Double check that. So that's our first calculation. Good. Okay. Next calculation, what would you do from there? Okay, so let's plug into the area formula. So we'll list the area formula we're using, and that's 7. And the root should go across everything. So just make sure that it's extended all the way over. And then we could do a quick simplification here. I'm just going to simplify all the brackets. You could, yep. Just do like all the brackets exactly as they're shown in the equation. Are you going to put in the square root as well, or are you just going to do the brackets first? Okay, yeah, you can do it all. Okay, so I'm putting everything now that I've simplified into the square root. You're going to try it the other way. See, make sure we get the same thing. I got 13,331. Let me see your calculator here. Let's see if there's, oh, that should be 150. Okay, so we should get 13,331.71. See see if that fixes it. Good? Okay, perfect. And what unit of measurement is that going to give us out? Close. What is area? Meters squared. Yeah, perfect. Okay, good. So the last thing that we need to take into consideration is that one big fertilizer costs $19.98 and it covers an area of 900 meters squared. So how do we use this area and that information to figure out what her total cost is? Or their total cost is? That's okay. That's why it's a lesson. I just figured I'd ask you first. Okay, so if we have one bag that covers 900 meters squared, I need to see how many 900 meters squared are inside of that area right there. So we're going to divide that answer by 900 and then multiply that by the price per bag because that will give us number of bags. So let's do a calculation. This will be our third calculation for number of bags. And then we'll do a calculation for cost. So I'm just going to do 13,331.71 divided by 900. This will be meters squared for both of these. And you can even just keep the answer that you had in your calculator if you still have it. Okay, so this rounds to about 14.8. Can I buy 0.8 of a bag though? So how many bags does she need? Or they? I think it says she. Okay, so therefore 15 bags. In there. 13,331. Okay, and then finally, if we know the cost per bag, and I know I need 15 bags, how do I calculate that one? Yep. So let's do cost equals 15 bags times, what was it, 1998. What'd you get? Yep, 2.99 and 70 cents. And give me a therefore. Perfect. Good. All right, last one. So choosing formulas and converting measurements. So we have a landscaper using a bucket with a radius of 18 centimeters, shown over on the right here, and height at 18 centimeters to pour soil into a rectangular planter that measures 1 meter by 40 centimeters by 20 centimeters. How many buckets of soil are needed to fill the planter? So anything that you notice to start here? About the units of measurement? all of it though. One is in meters. So the first thing that we need to do is address that. So how many centimeters are inside a meter? Centi means 100, if that helps. So it's 100. So it's, well, if we're multiplying, if we're switching from like a larger measurement into a smaller measurement. So 1 meter contains 100 centimeters. So we're going to state that 1 meter as 100 centimeters to start. Okay. How many buckets of soil are needed to fill the plant? Any thoughts on what that represents? Like if I'm filling something, is that area? Is it volume? Is it, well, it's really only two options, area or volume? Volume. Okay. Do you remember what volume of like a rectangular or cube is? No, volume equals length times width times height. Does that ring a bell? No? If it doesn't, that's okay. Okay. Okay, so let's calculate the volume of the planter using that formula. So this is volume of anything that's like cubed or rectangular in 3D rectangular prism, I think we call it. Okay, so length, 100 centimeters, width or depth can be 40, and then height is 20. Great. Any idea on units of measurement for volume? Centimeters, close, that's for area. Cubed, yeah. That makes sense, right? Because I did centimeter times a centimeter times a centimeter. So I multiplied 3 of them, right? To get cubed. Okay. What else do we need to know? I need to know how much this can hold, and then how much a bucket can hold, right? Because if I'm pouring from the bucket into the planter, then obviously I would need to know how much fits in the bucket to determine how many buckets of soil we would need. So let's do volume of bucket as well. So that requires volume of a cylinder, which is pi r squared h. So this connects to the size of the circle that cylinder is based on, and then the height of the cylinder as well. So we know that radius is 18 centimeters and height is 18 centimeters. And we're going to use the pi button on our calculator rather than 3.14. We can just plug it all in at once, that's fine. Great. And we'll round to the nearest hundredth here, so I'll say 7, and this is still volume, so centimeters cubed. Okay, and then lastly, how do I answer this question? So how many buckets of soil are needed to fill the planter? Yeah, perfect. So we'll say number of buckets equals 80,000, the total we need to fill. over 18,321 times 0.77. And let's round to the nearest tenth. Yep. All right, give me a therefore. We'll just say 4.4. Perfect. Great, that's it.